You know, we're all pretty obsessed with what AI can do, but today, let's ask a different question. What does it all cost? And I'm not talking about money, I'm talking about resources. We're about to dive into the surprisingly huge environmental footprint of the tech that is literally changing our world.
So you've probably seen this floating around online, right? It's dramatic, it's shocking, and it's definitely designed to make you stop and think. 6 whole liters of water. Poof, gone. Just for asking one simple question. But is that what's really happening? Let's find out.
All right, so we're going to break this whole thing down. We're going to separate the viral story from what the science actually says. Because, while the concern here is totally valid, the numbers we've been hearing, they're kind of way off.
Okay, this is where you can really see the difference. On one side, you've got this wild myth of AI guzzling 6 liters for every single query. But the reality? Well, researchers have found it's more like half a liter for an entire conversation of, say, 20 to 50 questions. And that whole underwater servers thing, that was just one single experiment by Microsoft. Almost all AI servers, like 99% of them, are firmly on dry land.
So what does that actually break down to? Well, per query, we're talking about something like 10 to 25 milliliters of water. That's like a tiny sip. It's not a giant bottle. So yeah, the viral claim is a massive exaggeration. But, and this is a big but, that doesn't mean AI is off the hook. Not at all.
Okay, so the 6-liter thing is a myth. Got it. But AI definitely has a very real and pretty significant water footprint. To really get why, we need to take a look inside these giant data centers. Just try to imagine a building packed with thousands of super powerful computers all running 24/7. They get incredibly hot. So the most common way to cool them down is something called evaporative cooling. Basically, water gets pumped through these big cooling towers, it evaporates into steam, and that process pulls all the heat out of the system. This is where the real water consumption is happening.
And that brings up a really good question. You might be thinking, so what? The water just turns into vapor, it becomes clouds, and it eventually rains. It's not like it's being destroyed. And you're right, it isn't. But that simple view misses a much bigger, much more complicated ecological problem.
See, the issue isn't just about the total volume of water used. It's about the consequences, the downstream effects of how and where that water is being used. These are the hidden costs that you don't see in that simple evaporation number.
So here are the 3 big ones. First, you've got local water scarcity. The water that evaporates from a data center in, say, Arizona doesn't just magically rain back down on Arizona. It might fall hundreds of miles away. That creates a net loss for the local community. Second is thermal pollution. Sometimes that hot water is just pumped right back into local rivers, which can seriously mess with the ecosystem. But honestly, the biggest problem of all is the absolutely staggering amount of electricity these things need, which leads to a massive carbon footprint.
And to really wrap your head around that energy problem, look at this. The process of just training one big AI model can create the same amount of emissions as 5 cars would over their entire lifetimes. That really puts the water issue into perspective, doesn't it? The energy consumption is the real giant here.
So yeah, it's a serious problem, but it's not hopeless. In fact, from an engineering standpoint, this is a fascinating challenge. The future isn't about stopping AI, it's about getting way smarter. And you know where the best ideas are coming from? The world's greatest engineer, nature itself.
This table here really lays out where things are going. We're trying to move away from that super water-hungry evaporative cooling. 2 of the most exciting alternatives are liquid immersion, where servers are literally dunked in a special non-conductive liquid, and geothermal, which taps into the Earth's natural, stable coolness. Both of these use practically zero water. We're talking about a huge leap forward in sustainable design.
And this isn't just some sci-fi theory, right? This is happening now. In Norway, they've taken an old mine and turned it into a massive data center. It's cooled using the constant deep earth cold from the mountain, plus cold water from a fjord right next door. It's just a brilliant way of using the local environment as part of the solution instead of just a resource to be used up.
And that leads us to maybe the most elegant idea of all, biomimicry. The whole concept is, instead of inventing some complex, energy-hungry machine from scratch, why not just copy the designs that nature has already spent millions of years perfecting? I mean, just look at a termite mound. It's an absolute architectural masterpiece. In the blistering heat of the savanna, the inside of that mound stays at a perfect, stable temperature, and it does it all with a complex system of vents that creates natural air conditioning. Now just imagine a data center built on that same principle, a self-cooling building that works in harmony with its environment, with no need for water and hardly any extra energy.
And that really leaves us with this final, fascinating question to think about. As we're building the future, what's the smarter path? Should we be engineering our technology to work with the natural world, adapting to its cycles and its systems? Or should our goal be to build completely self-contained systems, totally walled off from nature? The answer to that is going to define not just the future of AI, but really the future of our planet.